Allpoint Systems, based in Pittsburgh, Pennsylvania, focuses on automation-based robotics principles and the handling of 3D LiDAR and point clouds. Using technology derived from a fusion of computer vision and mobile robotics research, the company is dedicated to helping surveyors and engineers complete large-scale 3D projects faster and more efficiently. Products include ScanTime software, which allows users to view registered data live in the field, Insight, an online data review platform, and Bridges, a cloud-based software as a service for use in mobile mapping. With me today to talk about some of the latest trends in automation for LiDAR is Allpoint Systems founder and president Aaron Morris. Aaron, you have a doctoral degree from Carnegie Mellon University, where you focused on mapping underground spaces with 3D LiDAR. Since then, your focus has been on developing software tools that speed the capture and processing of LiDAR data. Why have you been so passionate about this area of research?
Well, to me, LiDAR and 3D it's an amazing area. When I did my graduate work at CMU, we built robotic systems that would explore underground spaces and build 3D maps and models. And from that, we could very quickly start to understand the state of the environment. The applications that we were looking for was in terms of safety and rescue, for example. Sending these scouts ahead in advance and coming back with information that you could relay to first responders, it saves lives. So the ability to use LiDAR and 3D to help very efficiently sort of the processing of our decision making was very compelling to me. And today, with the advent of some of these amazing 3D tools, the ability to capture very quickly, we want an equally quick and efficient means to extract the information. So that's why I'm very interested in 3D.
Sure. Now, you've been working on this for quite some time. What kind of challenges have you encountered?
There's all sorts of engineering technical problems to face. LiDAR is inherently very large and bulky, difficult to deal with. There's noise, so ideally you'd love a perfect data set, but somebody walks by and it creates a smear, or noise, or the sensors themselves create a little bit of noise. So there's a lot of spending a lot of time working through those and understanding people's applications and how you can tailor the data to meet those needs.
Sure. And over the last several years, what have been some of the biggest developments that you've seen with this technology?
Terrestrial laser scanning has been around for 15, 16, maybe up to 20 years, and has really innovated survey and engineering. The more recent was mobile mapping. Mm-hmm. So that came about 4 or 5 years ago, which also coincided with, I think, some of the activities around robotic systems. If you're familiar, DARPA had an urban challenge or a grand challenge in which cars would race around the desert or urban environments, autonomously navigating. Well, a lot of the technologies that were developed and created as part of those competitions were successfully won were related in LiDAR. And so about the same time you saw these mobile mapping systems come about. And to me, it's a revolution. You can drive now at highway speeds and just capture all this geospatial data.
And what types of things do you think we'll see over the next 5 years? I know you guys have been doing a lot of work in the BIM space.
Yes. So I think what you'll begin to see is a lot more direct interaction with the data itself. Before, the data was used as an intermediate step to producing like a 3D model. But now, design firms and companies producing software in the design space are starting to adopt the 3D natively so you can work directly in that. I think you're going to see a lot more cloud services, cloud processing. I mean, we definitely stepped into that simply because you can gain efficiencies in processing over a large group of people by having all the equipment able to process all the data right then and there, and a lot of people share in that usage. You're going to see a lot more technologies, data information sources, a lot more information being derived from the LiDAR. I mean, right now I think we're addressing some of the obvious things you can use the data for, such as design and sort of structural analysis. But as we repeatedly go and collect certain areas, we'll be able to do things like trend analysis and predictive analysis and use the geometry in ways that we really haven't even really focused or thought much about at this point.
Sure, that sounds exciting. Well, obviously your focus is robotics. Is there anywhere that robotics and automation can't go when it comes to LiDAR? I mean, where's the human development in all of this?
There's always a human in the mix. Robotics are fascinating. I know that, I mean, when I first started playing around and you develop a system that can drive by itself for the first time, you're hooked. But even today, the most sophisticated robotic system, especially in the autonomy, they're still very fragile systems. The world is very complicated. For example, our system, our robotic system, does well in large environments, right, where it's very tedious to go back and forth. Doesn't do so well when you've got small little corners or very niche areas to get into. But the combination of the robotic system with a human team creates a very efficient workflow for doing very large spaces very efficiently.
Sounds like a lot of exciting developments are in the works.
Yes.
Thank you so much, Aaron. I appreciate it. For more information about LiDAR and laser scanning, please visit geodatapoint.com.